Right, thank you. I have the pleasure of chairing this next session about the 4 presentations on the quality of reporting, and we'll crack on, as they say. So the first talk will be from Robert Frank, as you see, Association of Journal and Study Level Variables, and so on. You can read it. Please.
Hi everybody, my name is Robert Frank. I'm a medical student from the University of Ottawa, and the study I'm going to talk about today looked at the association of journal and study level variables with the distance between primary study results and summary estimates from meta-analyses. So there's been concern in the medical community that a lot of diagnostic accuracy research actually may be producing false results. Now, determining whether a result actually represents the truth or not is a bit of a challenge because truth is difficult to define. That said, summary estimates are generally considered to produce a higher level of evidence than primary studies because they produce results with less random variability. In particular, meta-analyses that use hierarchical pooling methods are less likely to overestimate diagnostic accuracy in comparison to traditional pooling methods. So with this in mind, summary estimates from high-quality meta-analyses should provide a reasonable proxy for the truth in diagnostic accuracy research. Now, clinicians often use surrogate variables to judge the quality of studies and the reliability of their results. However, none of these variables have actually proven effective in predicting the accuracy of primary study results or the proximity of these results to summary estimates from meta-analyses. So at the study level, while citation rate might seem like a valuable measure, the literature is actually split regarding its relationship with study quality. In terms of publication timing, the first study published on a topic or studies published before STARD was released might be at increased risk of deviating from the truth. At the journal level, impact factor and STARD endorsement might be associated with higher study quality, while cited half-life hasn't really been explored in this context. So the purpose of our study was to determine whether journal and study level variables were associated with the distance between primary study results and the summary estimates from meta-analyses, which was our proxy for truth in this study. If such an association were to exist, it would allow for the easy identification of reliable evidence to guide clinical decisions, especially when a systematic review is not available on that topic. So to gather our data, we searched Medline for systematic reviews of diagnostic accuracy using hierarchical pooling methods that were published in imaging journals between 2005 and 2016. We then reviewed the full text of eligible systematic reviews and extracted demographic data on the journal and study level variables of interest, as well as the sensitivity and specificity estimates from each meta-analysis, as well as each of the included primary studies. So for our analysis, the first thing we did was we divided all the primary studies into 2 groups on the basis of each variable. So for the quantitative variables, we dichotomized by median split. And then for the remaining variables, we divided as first versus subsequent publications, publication before versus after STARD, or STARD endorsement versus not. Once we had 2 groups for each variable, we calculated the mean deviation of the primary study results from their corresponding summary estimates within each group. We then compared these mean deviation values between the paired groups for a given variable. A significant difference between the 2 groups for a given variable in terms of mean deviation would suggest that that variable is associated with the proximity of primary study results to the pooled summary estimates. So to carry out our statistical analysis, we actually had to combine a linear and nonlinear model where means and confidence intervals were obtained using bootstrap resampling and p-values were obtained using a t-test. Our desired level of significance for this study was actually 0.05 overall, but we employed a Bonferroni correction to mitigate any bias that might have been introduced by performing multiple comparisons. So as a result, each comparison had to yield a p-value less than 0.0041 in order to be considered significant. So overall, we ended up screening 961 meta-analyses for possible inclusion. 98 of these meta-analyses met the inclusion criteria, which yielded 1,458 primary studies in the final analysis. So these plots here show the mean deviations of primary studies from their corresponding summary estimates for each group that we looked at. The top 2 graphs are for sensitivity and the bottom 2 are for specificity. On the y-axis, we have the value of the mean deviations for each group, and then on the x-axis, we have the groups identified. So from left to right, we have impact factor above and below the median, start endorsement versus not, cited half-life above and below median, citation rate above and below median, publication after versus before start, and then first published versus subsequent publications. The error bars here represent the 95% confidence intervals of the mean deviations for each group. So the important thing to note for these slides is that the confidence intervals are clearly overlapping between the paired groups in each set. So the appearance of these data strongly suggests that no significant difference existed between the paired groups for each variable, and this was supported by our statistical analysis, which yielded p-values greater than 0.0041 in all comparisons. So our interpretation of this data is that surrogate variables such as high impact factor, high citation rate, start endorsement, and later time of publication are not associated with primary study results that are more reflective of the truth, at least as established by meta-analyses. So the fact that we didn't find any association in this study is actually not very surprising. Ours is not the first study to suggest that impact factor is a poor measure of individual study quality, especially since it's so easily skewed by a few highly cited studies in the journal. Even so, the literature actually shows that the main drivers of citation rate are actually the availability of a study's results or the applicability or utility of its results to other journals or to other studies rather than the actual quality of the study. Finally, just because a journal endorses START, it doesn't guarantee that all of the studies it publishes are going to have complete reporting as per START guidelines. Even if they're completely reported, many studies will have important sources of bias listed in the limitation section, which may not result in non-publication of that study in a START endorsing journal. On the other hand, a journal or a study that's very well reported and has very minimal bias can easily be submitted to and published in a journal that doesn't explicitly endorse START. So the main limitation of our study is related to the abstract nature of truth. Although summary estimates are generally considered to be the highest level of evidence, this is only really true for well-performed systematic reviews of high-quality primary studies with sufficient homogeneity. Because in our study we didn't formally assess these characteristics for our included meta-analyses, it could be said that our proxy for truth is imperfect. Also, our approach to statistical analysis, where we dichotomized a few continuous variables, is also imperfect in that it may fail to identify some more subtle effects that are present in the data. However, we thought that this was a necessary approach in order to facilitate ease of interpretation of our results by a general readership, as well as provide a consistent presentation of the results between continuous variables and truly dichotomous variables. So based on our findings, the use of surrogate variables to judge study quality and reliability cannot be advised. Instead, we would recommend the critical analysis of individual studies, possibly using a validated tool such as Quaddus2 in order to predict the likelihood of bias in a study's results. Thank you very much for listening, and I'd also like to thank the organizers for giving me this opportunity and my co-authors for their support and hard work on this topic.
It's open for questions, and while people are thinking about that, can I ask you if you had problems caused by poor reporting of the systematic reviews that you were reviewing, and whether that hindered the acquisition of the relevant information?
It did. It actually limited the number of meta-analyses we could include, because one of the criteria was that they had to report their sensitivity and specificity estimates, and either the 2x2 data or the sensitivity and specificity for each included primary study. And a lot of them just didn't do that. So we had to eliminate a lot of meta-analyses just on that basis.
Okay, thanks. So this is a rare opportunity to discuss something that's not randomized trials. And I think I'm hoping that before I ask another question, that someone else would like to join in. Okay, thank you.
Hi, Sharon Quimby, American Academy of Neurology. Who do you think is best able to determine whether these manuscripts meet the criteria? It's a little distressing that papers are published without that requisite information. And who should be looking at these starred checklists to make sure that all the T's are crossed and I's are dotted? Because I'm not always certain that editors and reviewers are paying attention to these things.
Yeah, so that's a good question. I think it kind of goes back to Dr. Muller's presentation in that it should be the reviewers and the editors of the journals that are doing the publishing. And they should be adequately trained, and it should be enforced that they should be looking at these checklists and making sure this is done. Another option would be for the submitting authors to go through the checklist and identify how they've addressed all of the required conditions.
So, Malcolm MacLeod from Edinburgh, you show that these surrogate measures of whether we should read journals are not much good in determining whether the results are true or not, but then propose that instead we should use some article level measures of the quality. Have you then shown that those article level measures of the quality give you a better prediction of what's closest to the meta-analysis estimate than the approach that you proposed first of all?
The short answer is no. We haven't shown that. That's actually a great idea for a future study, though. Thank you.
Okay. Well, thank you very much indeed.
Thank you.
I think